Welcome to this video tutorial. In this video, we will continue our small virtual reality combat prototype. Specifically, we will be looking at collision geometry of our opponent, and we will be fixing a number of small little problems and adding some little features. Essentially, we want to go from this character and this opponent character that we created in the previous tutorial, and we want to go to something that looks a little bit more like this. Here you can see there is mesh colliders from each of the body parts, and we have to make sure that these mesh colliders are compatible with PuppetMaster. Also, you can see a little detail up here. We even added an additional little collider for the nose. And one of the goals for this tutorial is to add different functionality for each of the body parts that we define. Before I explain how to adjust this collision mesh, I want to tackle one of the small bugs, or I guess one of the unfortunate features that we had to deal with when using PuppetMaster and the animator component in Unity. As you might remember in the previous tutorial, or in the previous tutorials, I had problems with the character misaligning with the PuppetMaster hierarchy. So just to recap, we have two different hierarchies in our opponent character. The blue one here is the original prefab, and this is the actual rig that contains the bones of the character and that drives animations and so on. So this is the character being rigged, and that was most likely being built in some external program. Now PuppetMaster comes in and creates its own hierarchy that contains a collider, a rigid body, and a configurable joint so that it can be driven by physics. And then it maps each of those game objects that present a muscle and maps them to one of the original bones of the original rig. Now the problem occurred when those two rigs, so the PuppetMaster rig and the original rig, misaligned. And I found out that this always happens when I go into the animation window here. And so we have to click on the object that contains the animator, and then we have the timeline, and this is our boxing animation. And whenever I just go in here and screw up the timeline, maybe because I want to add an event, or I want to delete some keys, or make some changes to the animation. And even if I just go back here and just click on preview to cancel the preview, character's looking just a little bit more upward here. And if I go back to my PuppetMaster rig, I can see the rig is completely misaligned. And that was the problem that I had, and this really consistently happens. That is because whenever we leave the animation window here, there is the character's just left in some state that really misaligns sort of the frame of the animation and kind of leaves the rig in a weird state. So we need to find a way to reset our bones in our rig. Now I contacted Partel, the author of PuppetMaster, and he created a small little script that should help with this. And this is the script here. It's called Reset Pose. And it really just stores the local positions and rotations of each of the bones of the character, and then you can reset those. So basically, you set up your PuppetMaster rig, so your dummy with everything attached that you want it to be. And before you even deal with any animations, you just attach this little script to the game object that contains the animator, which is your root, where all of the rig is underneath, all the bones are underneath. And then you store your pose, and whenever this misaligns, you can simply just reset the pose again. And I will link this little script below. Thanks for Partel for creating this on short notice, and that should fix that problem. I also found out that there is another solution to this. Now that's because I am using a small tool called Scale. So if I just go on the game object that contains my skinned mesh renderer, then I have these two little green buttons here that belong to Scale, and I will link Scale in the description below as well. I can click on Start Edit, and this gives me this little window here with all the different tools. And there's one button that's called Reset All Bones, the R button here. And if I click that, you can see our character also goes back into its original state. So both of these are very useful, either the script from Partel or Scale if you use it and if you have it. And that should really should get you back on track. Because the problem is once the once the hierarchies are misaligned, there's no just undo. So the normal undo of Unity within the editor will not fix this. Now that's a bit unfortunate because we might in the future have to mess with animations quite a lot. So then every time we might have to go back and reset the pose. All right, but at least now we don't have to start from scratch every time this misalignment occurs. Right, so next we want to look at our collision geometry. You can see the collision geometry here of this original character that we have is exclusively primitive. So we have box colliders and we have capsule colliders, and that's about it. Oh, there's a sphere collider. Now, obviously, this is not very accurate, and we really want to make sure that we have as accurate a collision as possible. The other thing is that those colliders don't necessarily match the hierarchy of our rig. So, we have hands and we want fingers, we have different parts of the spine, we have a lot of different areas that are not really covered and just like covered in one larger collider. And what we want to do instead is we want to find a fine-grained sort of distribution of colliders that firstly follows our character. That's the important part. And secondly, that also more closely matches the hierarchy of our character, so that we might have something for the chest, and we might have a collider for the throat. Now, how did we achieve this? Well, the problem is that you cannot just go and maybe go to your skinned mesh renderer and just add a mesh collider. This will not work, because the problem with these moving characters, so if you animate your character or if you use inverse kinematics, then the collision of your body parts is really dependent on your hierarchy. So usually what you would do is, if you don't use PuppetMaster at all, you would go into your rig. So this is the original rig here, all the bones, and you would add a collider to this. So most often you would just add a primitive. And this is exactly what we did here with the PuppetMaster rig, but instead of adding it to the original rig, we added it to our PuppetMaster hierarchy. So here we have all our box colliders and head collider, like the sphere collider, and so on and so on. So just using a mesh collider will give you usually one collider because your character is one mesh, and will not allow you just to attach these different parts to your different body parts. How do we do this instead? Well, I found a nice little tool, and I used it for a different project, and I really had no idea it existed because I was looking for a solution for this for quite some time. And because what it does is it creates mesh colliders and automatically attaches them to each of the bones of your hierarchy. And that's just the first part. The best part of it is actually, and I'm using this for a separate project, it updates those colliders dynamically. So the connecting areas between those different bones will actually be updated with the collider deforming as your mesh deforms. So as your skinned mesh underneath deforms. So essentially you can animate your character, you can drive it by inverse kinematics or whatever you like, and the collision that is really close to your mesh will update automatically. So you can really either punch your character or really interact with it through physics collisions. And that is fantastic. Now we have one problem in this project here, because this functionality somewhat interferes with PuppetMaster, because PuppetMaster just works a slightly different way compared to a normal character. Because instead of adding our colliders to the original rig, we need to add them to our PuppetMaster rig. And that's a manual process, so I will just show you what I did here and how I set everything up. So let's disable our completed dummy and go to our work in progress. The first thing we need to do is, obviously you have to import RASCAL into your project. And then you need to find the game object that contains your skinned mesh renderer. In this case, it is not this top level dummy here, but it is the one underneath. And here you see the skinned mesh renderer. If you don't have Skillet, then you won't see those two green buttons, but that's no problem. And what you do now is you simply add RASCAL Skinned Mesh Collider as a component to it. Now, as you can see, all of these bones have nothing attached. They're just transforms that are used by Unity to define the rig of the character. And what the script now can do is it can generate those mesh colliders. Now there's a number of settings here, but we will just leave everything as it is right now. There's lots of exceptions. You can separate those colliders by materials, and you can exclude body parts that are that have certain materials applied, and so on and so on. But in our case, I will just click generate. And what you can see now is when we're actually going to our hierarchy, which is just this other game object here above, it created a very tight, perfect collision setup using mesh colliders. And it is not just one mesh collider, but it instead attached mesh colliders of each of those body parts individually to each of the bones. And that's actually, if you set this up manually, first of all, you have to split up your mesh and create those colliders, and then you have to attach them to each individual bone. Whereas RASCAL does all of this for you. That's great. And what we can do now is, or what we have to do now, is to copy those mesh colliders over to the corresponding body parts in our PuppetMaster hierarchy. And that, of course, is a manual process. It's a bit painful, and a lot of things can go wrong. But that's basically the way to go about it. You could probably automate this. You could probably also modify RASCAL to work with PuppetMaster, so that would be, I guess, a bit of a more complex integration. Maybe that's something that the author of RASCAL might do in the future. I don't know. But for now, we basically just have to go in and update this. All right, so let's get started with something easy. Let's take the head. So what we do is we go to our head here in our original hierarchy, and let's have a look at those colliders. And it actually attaches multiple colliders of the same thing. But it seems like there's two unique colliders. Something about the ears, or whatever our dummy has instead of ears. But I think the most important one is like this one here. So let's just copy the component, go up to our head in the other hierarchy, remove the sphere collider, and paste component as new. Enable it. There it is. All right, now just for demonstration purposes, let's hit play and see what happens. Well, first of all, there's some problems here with rotations, but that's fine. We can just ignore that for now. But the bigger problem here is that non-convex mesh collider with non-kinematic rigid body is no longer supported in Unity 5. And that's something I've seen over and over and over again, different projects, and it's something you have to deal with. So what we need to do is we need to change this mesh collider into convex. The problem is that it doesn't support that right now. Instead, we have to go to cooking options and to click on inflate convex mesh. And this will give us an approximation that encloses our mesh, but we inflate it slightly, which you can see there is a bit of a gap around it, so there's a bit of a buffer, which is something that, first of all, might be okay in terms of the collision in this boxing game, but you can also change this parameter here, skin width, which is the gap around our mesh. So if I leave this gap at 0.001, then this already looks much closer, much better. And sure, we don't get as many details as, for example, the nose here, but now it's a convex mesh, and it can actually work together with a rigid body that is kinematic. And the other problem that we have is that a convex hull can only have up to 255 polygons, so that mesh might be too complex. Actually, it might not be. I don't know. It definitely was before we inflated the convex mesh. But now let's have a look at what happens now. Now, this won't work, but at least you can see the head following around, or the collision mesh following around. The reason why this is not working is very simple, because we have colliders on our original hierarchy, and that is actually not supported, or that's not allowed. So we have to manually select all of those game objects that contain mesh colliders, and we have to disable them. Because if there's any colliders left in here, those colliders will interfere with the colliders that we have on our PuppetMaster hierarchy. Disable everything. Okay. And it's very easy to see whether we missed anything if we go to the root object here. There's no collider left that's highlighted, then all of them are disabled. Same here, if we go to the root object or the PuppetMaster object, we see all the colliders at once. All right. Try this now. And you can see our dummy already looks much better. Now he looks a little bit off because he has a look at script right now, so he's kind of being distorted by the final IK component, the look at IK. But already you can see the collision of the head is now much, much better than the original large sphere collider. Okay. So again, just to repeat, we select any of the game objects here in our original hierarchy, and then we copy the mesh collider, which has to be disabled here. Copy the mesh collider. Let's do the cough. We find the corresponding game object here on our PuppetMaster rig. So this was the left cough. So we choose the left cough here. We remove the collider that is in place, and we paste the mesh collider that we just selected over in the original rig. Now again, this won't work because the non-convex mesh collider will not play nicely with the rigid body. So we inflate the convex mesh, set it to convex. We might have to adjust the skin width depending on how accurate of a collision we want. And that's it. Again, we can play this and we can see that this mesh will now follow along much better. Okay. Now, on to the next step, which will make things much more complicated. So the problem is that, as you can see, the complexity of these two hierarchies, the original rig and the PuppetMaster rig, do not match. And that is actually a problem when we look at the mesh colliders, because I'll give you the best example. We have the spine, and let's for now just enable the colliders for the spine. And the spine is split up into 4 pieces. You got spine, spine 1, 2, and 3. Let's re-enable the mesh colliders for a moment. And even just the mesh colliders of these 4 pieces will only cover a certain part of the torso. There's actually then the clavicles, which don't even exist at all in our original in our PuppetMaster hierarchy over here. So what do we do with all these pieces? What do we do with the colliders? So let's have a look at this again. So now you can see there's actually even the neck involved. The neck is, I think, the most problematic one because it it covers the actual neck and part of the shoulder. But if you now look at this, this actually covers now the whole torso, but it's made up of a number of different game objects. And it's 1, 2, 3, 4, 5, 6, 7. 7 game objects. And over here in our PuppetMaster hierarchy, we have a spine, or a spine 1, and a pelvis. Actually, we didn't even include the pelvis over here as well, which is the lower part. But so we only have 1 game object here, basically, and we have 7 game objects over in our original hierarchy. So to get the most accurate results and the most detail in terms of collision setup, what we could do is replicate all of those 7 game objects over here. And that's a bit tricky. There's a number of steps involved, but let's go through them maybe just for the spine 1, 2, and 3, just so you get an idea of how it works. First of all, let's remove this box collider. We're not going to need it. Now, as you remember here, we have a spine 1 and a spine 1, 2, and 3. And the spine has the thighs and the other part of the spine as children. So what we could do is we could create an empty game object. Put it right here underneath the pelvis. Call it spine. And then attach those 3 game objects as children. Now I can already tell you without a lot of adjustments here, this will completely mess up your rig. So that's number 1. So it might be best to create a backup game object of this. So just duplicate it and set it aside somewhere. Make sure it's not a prefab so that if you update this here, it will automatically update. But instead, this allows you to then just delete this and go back to where you were before without having to like go through 100,000 undo steps. But basically, so we're now starting to manipulate this hierarchy here, which needs to include a lot of adjustments. So with the spine here now, we have spine 1, and then we want to create spine 2 and 3 before we get to the head. So what I'm going to do is I will duplicate the spine 1, put it underneath spine 1, call it spine 2. Let's delete those arms. Let's create spine 3 just underneath. And let's double check. The arms basically start at the same level of the head. So we take those 3 objects and attach them here. Now the arms actually don't start with upper arms but with clavicles, but that's fine. We ignore this for now. But this is basically now a better representation of the setup of the different spine elements. Now this is by no means is that done. We have a lot of things, a lot of steps to get through. Let's start with this spine up here. And the first thing we need to do is we need to attach the different objects. So attach a rigid body, copy component, and attach it here. And just for consistency's sake, let's keep the parameters of that. So the mass mostly the same as spine 1, so spine sort of has the same mass as spine 1. I don't know whether that's realistic right now. We might be able to tweak this later on. And we need a configurable joint. That's important because the joints basically define how much this whole rig can move around, and we'll play with that in just a moment. Okay. You can see when I open up this configurable joint, you see all these different arrows here, but we'll do that in a moment. Okay, so spine 1, rather spine. Let's actually rename this to the proper name. And now we need to make sure that it uses the same mesh collider. So those seem to be identical. So we select the spine and the original hierarchy here. We copy the mesh collider and go over to our PuppetMaster hierarchy and paste this mesh collider. Now we have a problem now because this collider should be the bottom, so it should be just above this joint here that our robot has. So if you compare this collider is too low. And that's because we need to change the transform. So we also need to copy the transform values. So right click on transform, copy component, go to our spine, right click on the transform, and paste component values. Now, Ignore for a moment that this will offset a number of things, because all of the things downstream here will be affected by this. So our arms are out of sync now, the head is way too high, but our spine now is correctly aligned. And you might be already able to guess, but we now have to do the same step for all the different parts here. We have to update all the transforms, and we have to copy over the different mesh colliders one by one. So let's do that. Let's go to spine 1. Again, I think they're identical. Yes. Let's copy one of them. Spine 1. Go to spine 1 in PuppetMaster. Paste component as new. Let's enable it. One thing we forgot, of course, here with the spine, it actually has to be also set to convex. Convex, and for now I'm just going with a skin width of 0.001 consistently, which gives a very tight collision mesh. And we do the same for spine 1, that we just copied over. So again, inflate convex mesh, convex, and here we are. Now this is again way too high. You can see there's a disconnect between those two spine parts. So we have to go to spine 1, copy the transform, and apply it to spine 1 over here. Now, you could easily create a script that goes through all of these components and copies over all of those components, all the transform values via script. And that's probably one of the next steps I'm going to do if I end up setting up multiple opponents with different hierarchies and so on. So that's going to be much, much easier. If you do this a lot and you spend hours on copying all of this rig over, it's best to just create a script, an editor script, which just has a button here that says copy, where you drag and drop in the PuppetMaster hierarchy, the dummy, the original hierarchy, and then just copy over, and you're basically done. But for now, I just want to understand what we have to do, and that all of this setup here is actually really just assemble. There's no voodoo magic to it. It's really just we have to get the mesh collider in the correct on the correct bone, and then we need to make sure that the transform is in the right spot as well. That corresponds to the original hierarchy. And ideally, we would want to set up the exact same hierarchy as we have in the original mesh. And that can include fingers, that can include everything. You just have to be careful to check what kind of mesh colliders are provided. But here you can see even the fingertip of the pinky has mesh colliders. So everything is supplied with a mesh collider. The only things I think that don't have mesh colliders that were created through RASCAL are the feet, or the first two toe elements. Now obviously our dummy doesn't have any toes, so it only has mesh colliders for the foot and the first toe. So it's basically the tip of the solid foot that this dummy has. Now if you have an actual humanoid, then all of this is going to be easier and you have actual toes. But really, you could go into as much detail as you want. If you care about breaking individual toes in your fighting game or interacting with different toes, then you could set all of this up, no problem. Now, there's one more thing to mention, and that is actually the configurable joint. And that actually requires quite a bit of fiddling as well. Since we copied the spine, so this spine I think is a copy of the original of this spine up here. Now this spine is connected to the pelvis. And you can see this here in the configurable joint, that the connected body is the pelvis. However, this spine here should be connected to this spine. So what you need to do is you need to change this pelvis, which was just copied, to this spine. And this, since it's auto-configuring the connection, automatically changes the connected anchor. And that's good. Now the next thing though is you can see those different colored shapes in there, and that is the amount of motion that this joint, this configurable joint, allows. And for the spine, which is sort of the bottom here, which I mean for this robot, sort of has a, he has a joint down here somewhere where he probably has a lot of freedom of movement, so his range of motion is probably fairly wide in terms of the different angles. But if you have just a normal humanoid, you only have fairly limited movement in each of these spine elements, because if you add all of those up, you're not going to be able to completely bend back and forth like 180 degrees to completely fold yourself. So there's a couple of options that you have here. First of all, you can simplify it by keeping all of the movement down here in this lower part of the spine, and this is already set up. You can see that in this configurable joint you have, first of all, X, Y, and Z motion is locked, so there's no translation. You cannot move this joint in any direction, but you can rotate it, and that's normal for a joint like this. The question is, how much can you rotate this in each direction? And this is what it's indicated here by those 3 different colored illustrations. Those represent the angles, so the high and low X is yellow, and you can even just adjust these by dragging this little yellow ball, and the same goes with the high X. So in this case, this joint can rotate, that amount of degrees, which is probably about 35 or whatever it might be. So low angular X and high angular X. So it's about 33 forward, no, 27.8 forward and 33 backward. And you can see as I move this, this value adjusts. So you really got to decide what is a realistic movement of this robot. Now, as I said, we might just keep most of the rotation here in the lower spine, and then the upper spine elements might have just either very limited rotation opportunity, or we lock them completely. So between low and high angular X limit and angular Y limit and angular Z limit, Z limit, you can decide whether you even want to lock any of the degrees of freedom. And then going up to this spine, I could, for example, lock this completely by going up here and setting this to locked. And I could also decide that I maybe just want to have a tiny little bit of movement in here by setting all of this to maybe 2 to maybe 3 degrees, so that it can only just wiggle just a little bit in each direction. But that's really something that you have to explore, and you have to see what feels right at the end. You could start by just locking all of those spine elements and keeping all of the rotation at the lower spine. Anybody with in-depth knowledge of human anatomy, if you know any physical therapists, they will be able to tell you exactly sort of what a fairly flexible or what a fairly stiff person, what kind of range of motion they have. Obviously, we're not replicating each of the parts of the spine that have all the many degrees of freedom that a human spine has, but instead it's simplified by just spine 1, 2, and 3. All right. Now, once you copy all of those mesh colliders over, you adjust your hierarchy here under PuppetMaster, and you set all the transforms up and all of the configurable joints. There's really a number of things you need to go through to make sure that everything works. So again, you have to make sure that this connected body is correct considering your new hierarchy. So if I go to spine 2 here, we have to connect it to spine 1. Spine 3 is connected to spine 2, and so on and so on. The head is now connected to spine 3. Now obviously down here the head is connected to the neck, but let's ignore that for now. So again, make sure that all of this hierarchy makes sense still in terms of the human anatomy and the rotation, the angular limits of your joints. Now there's a next step for this, because we created basically a lot of different, what PuppetMaster calls muscles. A lot of different zones of the body that need to be tracked and that need to transfer their physics interaction over to our original hierarchy here of our spine. Of our rig. So let's head over to PuppetMaster. So this is the object that contains our PuppetMaster script. And down here you see we have currently 13 different muscles, but we already added a couple of spine elements. So here we only have spine 1. You can see if I click on spine 1, I actually already, since I already modified this script, it now already has spine 1, 2, and 3 in here. But initially this will only have spine or spine 1 in here. So what we need to do is we need to go to the PuppetMaster script. No, it's actually not the PuppetMaster, it is the muscle script. So you open the muscle script, and at the very top here you have what is called group, an enum, and it has a list of all the different groups or muscle parts that we can define. And what I did here is I modified this list. So as you can see, I now have spine 1, 2, and 3, clavicle left and right, so all of the different parts that we need to replicate our character or dummy character. And what we now need to do is change the number here of our muscles, let's say to 20, and we need to make adjustments to this list. So let's, for example, take this right forearm here, and let's call this spine 2. So it's already set to spine 2, but basically then select whatever part it is here. So let's do spine 2. And then we go in this PuppetMaster hierarchy, we drag spine 2 over in this joint slot, which is a reference to our configurable joint. And now we need to define a target for it, which is down here in our original hierarchy. And we find spine 2, and the transform of spine 2 goes into the target slot. You can now choose the mapping weight, the pin weight. Ideally, at the start, you would just set all of this to 1, and that's it. And you do the same for spine 3. So you can see the name also adjusts automatically. So depending on which joint you drag in here, let's do spine 3. Go up here, spine 3, drag it into our joint slot, and the name adjusts to spine 3. And we find spine 3 down in our original rig, and we set the group to spine 3. Pin weight to 1, and that's it. And now here you really need to make sure that you update all of those individual muscles. For a moment, let's activate our dummy that's already been completed, that I worked on just prior to this video. Let's go to our PuppetMaster object here, and you can see I defined a total of 22 muscles. I even put a nose in, neck, and so on, and all of this is set up properly. Now keep in mind, this list here of groups is an enum, and that whenever you make changes to this list, so let's say I insert spine 4 here, then you have to go through this list again and double check whether all of this is set to the correct value. Because if you add a value in between, let's say I add a value very much at the beginning here, before hips, let's say I put something like pelvis, then all of these values will be wrong because they will be shuffled down 1. So instead of hips here, it will then say pelvis. And here it will say, instead of clavicle, it will say spine 3, and so on. So you will have to reassign all of those values because they will be wrong. So that's one of the things you might not notice when you make changes to your muscle script. And the other thing that really can go wrong, and that kind of kept me busy for a while because I didn't realize it, is you have to make sure that, let's disable the dummy I was working on. Let's keep the finished one. But you have to make sure that the original rig here, with all the fingers and everything, first of all, still has the mesh colliders, but they're disabled. The reason why we keep those mesh colliders around is, so first of all, I could go to the object, the game object with the skin mesh renderer here that has the RASCAL script, and I could just click on clear and get rid of all of those mesh colliders, and it does it automatically. It basically deletes all of those mesh colliders. Now the problem with that is that instead of just deleting the mesh collider components, it also deletes all the meshes associated with them. So since we copied all of those over into our PuppetMaster rig, hitting this clear button here on RASCAL will delete all of our setup that we just spent, a good half hour setting up in our PuppetMaster rig because it deletes all the mesh colliders that we created. So that's a no-go. Don't do that. What you can do is you can remove the RASCAL script. We don't need it anymore because we only used it to create those mesh colliders in the first place. So what you can do is you can either disable those mesh colliders, and I usually keep them around. I don't delete them because sometimes I want to go back. Let's say I add another joint somewhere or another zone that I need a mesh collider for that I haven't transferred yet. Then it's sometimes helpful to just to re-enable the mesh collider in this original rig here to see how things align and so on. So you could, if you delete this now, let's say I remove these mesh colliders from the pelvis, then obviously the collider stays, so the collider still exists. But there might be a moment when you actually want to re-enable some of the colliders here to just compare the collision or something like that, if something is not 100% aligned or so on. The only thing you really shouldn't do is use the RASCAL script and click on clear, because it really will delete the mesh colliders. And that will leave all of those references here. They're unnamed, those mesh colliders, but they will disappear. They're missing then. And there's no way to undo this, so be careful. All right. Now there's one other thing that I did here that doesn't use a mesh collider. And that is the nose. Let's find the nose. And nose is a box collider. The nose is a bit tricky because I want to be able to collide with the nose, and the reason why I'm using a nose here is because it might trigger something like a nose bleeding. So let's say I'll land a punch straight on the nose, and I want this to be different than just hitting the head somewhere. Same goes maybe for the ears. If the character actually had ears, if it were in the dummy, then maybe the ear starts bleeding or something like that. Or the jaw, you might actually trigger a broken jaw where you have some animation where the character will touch its jaw after a hit or something like that. So there's a number of like cool collision zones you can set up, but I wanted to just like for testing purposes start with the nose. And the problem here is that obviously with the inflated convex mesh collider of the head, we don't get a lot of detail here, especially in those concave areas, so the non-convex areas that sort of are in the inside of the mesh that kind of bend inwards. And that leaves us with the problem that we need to extend this nose beyond the convex mesh of the head. And that's why I had to extend this nose out a little bit. Now, there could be an edge case where the character, so the player here, will punch, but will never actually hit the nose. Will stop right here in those couple millimeters, and it will count still as a punch. But I think we can live with this. This is some inaccuracy, but we need to basically extend the nose collider a little bit beyond the convex head collider so that it can actually register and it's not hidden inside of the head collider. So what I did is I actually created this game object here. It has a configurable joint, but I locked it because I don't expect the nose to wiggle anywhere. I don't want any wiggling of the nose, any rotation there. So it is just locked. You can see angular motion, X, Y, Z all locked. Rigid body is, oh, that's a heavy nose. Let's do 0.3 as the mass. And it's just a box collider because as you saw, there is no actual mesh collider that was created for the nose by RASCAL. And then I set the muscle script up to also have a reference to the nose. So here in this list, the group now also contains a nose. I set it to this, and the joint is set to nose. In the original hierarchy here, there's no nose object. I actually added it here. Just thinking that, okay, maybe we use this as a reference point for if we want to trigger a bleeding particle system or something like this. And we could then move this really where the edge of the nose is. But we have to make sure that the reference in the PuppetMaster here to this transform is not to this new nose object, but instead to the head. Because the original rig is something we cannot easily change unless we use an external program where we re-rig the character, or where we use something like Puppet 3D where we even, add new bones to our rig. But instead, the only bone that is really being affected here and that we need to take into account when we hit the nose is the head. So let's say we punch this nose here. We want this punch and the force of this punch to be applied to the rigged bone of the head, so that the head bounces backwards, the head takes damage, etc., etc. I hope this makes sense. So the nose that we arbitrarily added here is not part of the rig. It's just for us something that follows along this head bone and doesn't have any direct connection right now to the rig unless we re-rig the character, which I don't plan on doing. So that's why this muscle group of the nose targets the head. Okay. Now that concludes, for now, the transfer of the collision mesh. The next thing I want to show and I want to briefly talk about, and this is already a fairly long video, I'll try to keep it brief for the rest, is adding different body parts. And in the last video, we had a body part head. That was the only one we had. And we assigned some health and max health to it, and we added a muscle to it. Now, this was all set up so that it points to the head, and it points to the different joint and target, so that's all fine. This is not really, this muscle is not involved in any of the physics transfer, because as you can see, this body part here doesn't have any physics, and no rigid body, no collision applied. This is really just sort of a reference to make sure that we're applying, or we're changing the configuration of that muscle, of that mapping weight accordingly. But what I added is a damage factor, hit events, no health events. And I'll explain that in a moment. Let's go to body part. No, instead, let's go to custom puppet behavior. And here on muscle collision behavior, this is what has been triggered whenever you hit one of those muscles. And if you go back to the previous video, not much has changed here. In fact, we are doing the same things all up to if target. All of these things are the same as in the previous video. But here in the previous video, we were handling all of the health deduction and doing anything that happens on impact. Now, the difference is that I want to be able to support different body parts and to allow those different body parts to trigger different things when we hit them. I also want to be able to allow each of these body parts to take different damage. So if we hit the temple or the throat, I want the character to take overall more damage and to be knocked out quicker than if we, for example, just hit a leg. So in order to have this functionality that's custom to each body part, I'm now just calling a function called impact on the body part, and we forward this muscle collision so that we can still get all of the information about the velocity and so on. But now let's go into body part, and here this impact function calculates the health, or the health that's being lost, adjusts the muscle weight, but then also triggers some events. So that allows us to, first of all, apply a damage factor, so sort of a percentage of damage being applied that we can adjust per body part. So damage factor up here, I put an attribute, range attribute 0 to 100, and this is a float, and then we multiply by this float divided by 100, so it's basically a percentage. I could also do this up to 200% or something, doesn't matter. And this allows me to go to different body parts, and here you can see damage factor, that's a slider from 0 to 100, that here the head applies 100% damage, but if we, for example, hit the hand of the character, it only applies 10% damage. So the hand will actually fall off or will trigger like a no health event much lower at only 10% of the progress than hitting the head. So that was that part. And we also include UnityEngine.events as a namespace. And then we have those two public Unity events, hit event and no health event. And the no health event obviously is only triggered when our health gets to 0 or below 0, and the hit event is always invoked. And this gives us this nice little interface here in our inspector that allows us to then add events. And this is something that I really enjoy doing, just exposing those Unity events and then being able to drag and drop certain things in. Now, we can add more events here, so you can add maybe events that have a certain health threshold, so not just no health, but also maybe a percentage health, so that maybe at 50% health of the head, or rather of the nose starts bleeding, those kind of things. There's really a lot of things we can do, and this gives us sort of a nice granular, sort of modular approach for each of the body parts, both in terms of the damage that's being taken and also of the things that are triggered when the dummy is being hit. And you can see here the head actually has a no health event, and that is a PuppetMaster kill. And PuppetMaster is here this game object, just drag and drop it in, and PuppetMaster kill basically means that the dummy loses any of its physics properties and it just falls over. In other words, it's a knockout. So, and that is really if the head loses all of its health, we knock out the dummy, game over. And that's really easy to set up once you have all of this, this individual body part sort of functionality. All right, I will upload those updated scripts, so mostly the body part and the custom puppet behavior. I believe I cannot share the muscle, or I'm not sure. I don't want to just get in trouble with Partel by sharing his script, so I don't have the copyright to these. So even if I modified it, you can just see it's really just the adjustment here of this group to include additional body part muscle groups. The one thing to note is that if you actually remove one of those muscle groups here in this enum, so let's say instead of arm, I want this to be arm left, arm right. Then you will see that the moment Unity recompiles, you will see a couple of errors popping up because there is arm referenced somewhere in other scripts. But this is then really just going, double clicking on those error messages. Maybe let's try this for a moment. You will see that here, muscle group does not contain a definition of arm. So here you can see arm. I already changed hand left and hand right. This was originally only hand. I want to differentiate between left and right hand. But here I now would have to just change the arm left. Or arm right. And that's sort of the kind of changes you need to make. Now that I changed this hierarchy, this list again, as I mentioned before, I would have to go back to my PuppetMaster and I would have to change, upper arm now, forearm, all of those things now. As it recompiles, I still have to make some more changes here. Oh, you can see that there's more things I need to adjust. But once all of these errors are being handled and adjusted, I have to go back here in this hierarchy and make sure that all of those groups are correctly assigned because I changed the enum to have more options in there. All right, I think I'll leave it with this. If you have any questions, please leave messages below. I will get back to you as quickly as I can. But really just to summarize, we updated the collision geometry to be much more well-defined for the dummy. We found two potential solutions to the misalignment problem. And we also enabled the per body part behavior, both for unhit events, no health events, scaling damage, etc. So those are the things we accomplished, and I will get back to you with a new installment of this video once I made some more progress, as this is really just a small side project. I hope this was useful in any way, and if you sort of start a similar project or you want to work on a combat VR prototype, please let me know, maybe post some short video or something, I'd really love to see if other people are just experimenting with this. For me, it's really just mostly a learning exercise, because a lot of the tools that I try out here and that I implement, I can then reuse in other projects, and that's been really helpful. All right, thank you very much for watching, and I will see you next time.